All right, this is AP Calculus BC. We are on the first pretest for our unit that is just known as basics because it's a bunch of kind of miscellaneous things. Yeah, so this is going to be the key. First question, how many inputs and how many outputs are there in a polar function? So there's only one input, and that input is theta. So put theta here. And the output, there's only one output, and that output is r. Because remember, you'll have some sort of equation like r is equal to sine of, I don't know, 3 theta, and then you'll graph that. Cool. Number 2, what variables are used in a parametric function? So parametric, those typically look like this. I'll give you an example, like x is equal to square root of t plus 1, and then y is equal to, I don't know, t squared plus 7t minus 8, some weird things happening. And yeah, so your variables are x, y, and t. You have to have 3 variables where you have one input. I'll write this down too just in case it shows up on the test. You'll have input, that's not how you spell input, input, one input, and then outputs, 2 outputs. Number 3, sketch the graph of the following function. So there it is. If you forgot how to do these, that is totally okay. We can do them really quickly together. But we should generally know that that looks like an oval whenever I have a sine and a cosine, and then the dimensions of the oval, 4 and 6, that will be, I think, since the y has a coordinate of 6, I'm going to guess, I'm unsure of this, but since it says y, I'm going to assume that the y coordinate goes out to 6, and -6, and then the x coordinate goes out to 4, -4, -4, and 4. It's going to be like some sort of ovally shape that goes like that. Let's actually check though. How would I do this if I had no idea what was going on, which maybe are some of us? So I make a table. I make a table with t values. Let me zoom in here so I can actually work on the table a little bit easier. I have t values, and I have x values, and I have y values. Again, parametric function has tx and y. So t, I'm going to choose a nice value. 0 is usually the first one I do. So what if sine of 0? So sine is asking for the y coordinate at 0. Y coordinate is 0. Okay, so 4 times 0 is 0. Done. What about y? So y is cosine. Cosine of 0 is 1. 1 times 6 is 6. So I'm going to graph the coordinate 0, 6. This coordinate right here, 0, 6. So 0, 6, and hey, it was exactly what I said. On the y coordinate, on this y, or not y coordinate, on the y-axis, we have the y-intercept of 6, and also -6. How do you get -6 down there? Well, I have to somehow make this cosine instead of 1, make it a -1. So where do I have cosine of -1? Cosine of -1 happens over here, and that's pi radians. So I would have to plug in pi. So I plug in pi. Sine of pi is 0, and cosine of pi is -1. -1 times 6 is -6. There it is. This is going to be that point right there, 0, -6. I'll get rid of this guy too. How do I get some other points? So I could try plugging in other values like pi over 2. Pi over 2. So sine of pi over 2, that's the y coordinate of pi over 2. Pi over 2 is pointing straight up. So the y coordinate of that is 1. So sine of pi over 2 is 1. 1 times 4 is 4. And then cosine of pi over 2, that's the x coordinate of pi over 2. X coordinate is 0. So 0 times 6 is 0. So I'll get the coordinate 4, 0, 4, 0, which is that point right there. And then alternatively, 3 pi over 2, this one will still be 0 for the y coordinate, and the x coordinate will be -4 because sine of 3 pi over 2, the y coordinate of 3 pi over 2 is -1. -1 times 4 is -4. So those are your basic setups, and you should know it looks like some sort of ovally shape. It doesn't matter how perfect your oval looks. Okay, so if my poor drawing is any measure of accuracy, if you can do my drawing or better, you're in good shape. and it can probably be worse. This one didn't look too bad. Number 4, evaluate the following expressions. So whenever I divide by infinity, it doesn't matter if it's positive or negative, this is going to be equal to 0. This one's going to be a little bit tricky. So this is going to be the same thing as infinity to the negative 2 over 1, which is going to be whenever I have a negative exponent, I flip and then turn it positive. So it's going to be 1 over positive infinity to the positive 2, and we know that's the same thing as 1 over infinity, which is the same thing as 0. So the first two answers were 0. Is this going to be 0? No, it's not. Okay, so let's simplify this a little bit. This is going to be 2 to the power of infinity. That is infinity. Anything to the power of infinity where the base is bigger than 1 is infinity. And then plus, okay, well, 3 times 1 is times negative 3. So this is times negative 3. And then any negative times infinity is negative infinity. Number 5. We have this polar graph, and we need to draw the radius at these two angles. So 7 pi over 4. Where even is 7 pi over 4? 7 pi over 4 is, it's not 5 pi over 4. So 5 pi over 4 would have been this middle. Whenever it's divided by 4, you're thinking of some middle coordinate, like pi over 4 is that middle, or 3 pi over 4 is that middle, 5 pi over 4 is that middle. The only one we haven't talked about is 7 pi over 4, which is that middle right there. So I basically just wrote the answer, but I want to make it a little bit neater. From the pole through that line, and it's the radius, so don't go too far. Boom, there it is. And we can label it too to make sure that we really know what's going on. This coordinate right here is 7 pi over 4, or the angle rather. Okay, so what about 7 pi over 6? It's really close to 7 pi over 4 in terms of the numbers. 7 pi over 6, and it's kind of cut off, but this corner right here says 7 pi over 6. So the radius that I draw goes from the pole to that point right there, and then make that look nice. All right, cool. Those are the two different radii that you're supposed to draw. And again, you always go from the pole to wherever you intersect the curve. Number 6, for what values of theta do you have r is equal to 0? And it is including 0, it is including 2 pi. Those, I know, tend to trick a lot of people. So on this one, r is equal to 0. So there's, again, two ways of thinking about this function. My favorite way of doing this is as I am on like an observer or an ant or something on this curve, and I'm approaching r is equal to 0, I'm approaching this pole here, what angle do I get closer and closer to? That is, as I move in here, maybe I should use a different color so it's easier to see. As I move closer and closer and closer, which of these lines do I get closer to? And it's pretty clear that you get closer to this pi over 6 on that line. So one of our answers is pi over 6. I'll write it up here. One of our answers is pi over 6, and maybe I should say theta is equal to the following values. What about this next one? I'm just going to kind of go counterclockwise. That's usually what we do in mathematics. What about this curve? I'm getting closer and closer to the pole as I get closer and closer to this pi over 2. So come back over here and I say this is going to be pi over 2. Next one, this curve is getting closer and closer and closer to 5 pi over 6. So the next one is 5 pi over 6. Next one, so this curve is getting closer and closer and closer to 7 pi over 6. So come back here and say this is going to be 7 pi over 6. 7 pi over 6. Next one, I'm getting closer and closer and closer to this 3 pi over 2. So 3 pi over 2, 3 pi over 2. Just have to say it 3 times, right? And our last one, this gets closer and closer to the pole at, it looks like it's actually touching, but it's not, and it's 11 pi over 6. So our final answer is 11 pi over 6. And we can make that 6 slightly neater. Cool. Those are the thetas. And yeah, we didn't have to worry about the bounds 0 and 2 pi, luckily. Sometimes you will on other problems. Number 7. Given our equation, ooh, that guy looks rough. Find all values of theta that make r is equal to 0. Whew. Okay, so I'm just going to go ahead and say r is equal to 0. So 0 is now equal to cosine of theta sine of theta plus sine of theta. I could just probably stop writing the parentheses, it would be faster, over cosine of theta. I'm going to subtract this product from both sides. So I'm saying, I have technology so I can speed this up a little bit. What I'm saying here is I'm going to make this yellow and this yellow. What I'm doing to both sides right now is I'm subtracting cosine and sine, cosine times sine from both sides of this equation. So 1 here and 1 here, which will cancel these out. They're gone. And what I'll be left with is this thing. Cosine theta, sine theta, a negative cosine theta, sine theta on the left-hand side. And on the right-hand side, this sine of theta divided by cosine of theta. Oh man, I love copy pasting. It makes my life so much simpler. Okay, so, in order for these both to be equal, well, let's go ahead and find all the bad values. So there's nothing I can really do. Oh, I can cross multiply. Ooh, okay, so I have a fraction equal to a non-fraction. Now I have a fraction equal to a fraction. Whenever I have a fraction equal to a fraction, cross multiply to solve. So let me make that slightly neater. I'm going to cross multiply this side. And what happens when I do that? I get negative cosine squared of theta sine of theta. It's going to be equal to sine of theta. And what I want to do is divide both sides by sine of theta, but I'm worried. What if sine of theta is 0? Then I'm dividing by 0. Can that ever happen? It could, because cosine of theta can never be 0, but sine of theta might be equal to 0. So we have to be careful about how we do this. So I guess we'll just account for that. So where does sine of theta and sine of theta equal? Okay, these sides will only be equal if sine of theta is 0 and sine of theta is 0. I hope that everyone can see that. So if this is 0, then 0 times cosine squared of theta is also 0. So one of the answers, just kind of logically inferring here, is where sine of theta is equal to 0. That is one of the answers because that will make the left and right sides equal to one another. So this is asking the question, where do I have a y coordinate? I'm putting that in quotes because this is not really what I'm saying. But where is y equal to 0? Y is equal to 0. I'm making my quick little unit circle. That means on my y-axis I'm not moving up and down, so it's here and here. That's when theta is equal to 0 and pi. So 0 and pi. Those two answers will always, and 2 pi. Be careful here because 2 pi is actually included in our bounds here. So 2 pi could be equal to, so I do have to include that value too. Oh my gosh, where am I scrolling? So those are the three things that will solve the equation, but some of these might be bad values. What I could also do, this is not mathematically legal, but it's a way to kind of understand what I'm going to be talking about here. I know I'm being illegal, I'm sorry. Divide both sides by sine of theta. Even though we've clearly shown that sine of theta might be 0, but we're going to say, hey, assume that we don't get 0. What happens in that case? If we can assume that, then I can say, okay, now divide both sides by sine of theta. Divide both sides by sine of theta. And I get chunk, those are canceled out. Well, canceled out and left with 1, right? 1 is now on the right-hand side, and this is saying negative cosine squared theta is equal to 1. So I need to do some more work. Sorry, you're going to get pushed into a corner because we need more room. Where do we have room for you? You are going to go into that corner. And then continuing to solve this equation right here. So I'm going to come up to right here. So I'm going to multiply both sides by -1. That's a nice easy step. So just transferring the negative sign to the right side. So cosine squared of theta, I love how my handwriting gets nice and messy when I zoom out, is equal to -1. all I did was multiply left-hand side and right-hand side by negative. Or you can divide both sides by -1 if you want to do it that way too. And then finally, I'm going to square root both sides. So I'm going to square root the left-hand side, I'm going to square root the right-hand side, and that's a problem, isn't it? That's a problem because that will never happen, because the square root of -1 is imaginary, so you have an imaginary unit. But in all of AP Calculus, A, B, and BC, this guy does not exist. So not in AP Calc, which means if I'm not allowed to go to imaginary numbers, the answer here is D and E. So this doesn't happen, D and E, which means, go away alarm, I'm supposed to wake up right now. That means that those are the values, but there's more, so we have to be careful here. So we've shown that there aren't any answers that come from this. There are answers that come from this, but notice that we have bad values. I have to exclude wherever cosine of theta is equal to 0. So whenever you have a fraction, like any single time that you have a fraction and you're looking for all possible values that work, always set any denominator equal to 0 to find all of the bad values. So bad, all caps, when equal to 0. So I know my work is all over the place. So I'm going to come down here and work on that. So where does cosine of theta equal 0? Well, that's asking me, let me zoom in here now, that's asking me where's my x coordinate, and I'm doing this in quotes because it's not really what I'm saying. Where's my x coordinate equal to 0? I go on my unit circle. My x coordinate is equal to 0 whenever I'm here or here, because that's my x. I'm not moving left or right, and that happens at pi over 2 and 3 pi over 2. Okay, so if I see any of these values, I'll say down here, theta is equal to pi over 2 and 3 pi over 2, and I'm going to label these again. These are my bad values, all caps, bad values. So if I see these values, cross them off. Okay, so here are answers. Do we need to cross off any numbers? No. Okay, there are no bad values. So there's my answer. I'm going to go ahead and box it. Number 8, convert to a Cartesian equation. So whenever you're converting to Cartesian from, wow, I'm blanking on the word, parametric form, you just need to somehow get y equals something with x. So the general idea is solve one of these things for t. So solve for that t. Oh, there's 2 t's. Oh, this one only has 1 t, so let's solve for that one. I'm going to square both sides. So this is squared, and that becomes x squared is equal to t plus 2. And finally subtract 2, so that's going to be x squared minus 2 is equal to t. Cool. So now I've solved for t. Oh, what happened there? That t is x squared minus 2, which means these t's are also x squared minus 2. So now I'm going to say y is equal to, that's not a t anymore, it's an x squared minus 2. I'm rewriting this equation right now, and that has to be squared because that t was squared. And then I'm going to say plus 9t, but not t. T is x squared minus 2, so x squared minus 2. And then don't forget to subtract 36. You're basically done when you get to this step. This is a Cartesian equation. If you want to be really formal about what's happening and trying to boil this down to the most simplest form, which I really appreciate you doing, because you might be able to see some more patterns happening. Let's do that to show you, but you'll get full points as of this step right now. So in order to see what's happening further, whenever I square a binomial, you're going to square the first. I squared this first term. I'm going to double the product, this times this, so negative 2 times x squared is negative 2x squared. Negative 2x squared, double that is negative 4x squared. Negative 4x squared, negative 4x squared, and then square the last. So negative 2 squared is positive 4. Positive 4. Cool, I'm going to distribute this 9, so this is going to be plus 9x squared minus 18 and minus 36. Almost done. Simplifying this one more step, y is equal to x to the power of 4. I have some x squared terms I can add together, so it's going to be 5x squared. So plus 5x squared. And then I have 3 of these constant terms. So let's see, how the easiest way to do this, I think, is 4 and negative 18 makes a negative 12. And then these are both going in the same direction, they're both negative, so I have a negative 12 and a negative 36 now. These are not fractions, I'm just saying this is our new problem. Negative 12 and negative 36 is negative 48. So come back down here and say those 3 give us minus 48, and I'm going to box the 2 answers. Like, you could have said this, but I really, really appreciate those of you that did this. Number 9, convert to a Cartesian equation. Again, okay, so whenever I have anything that has sines and cosines in it, you need to use what's called the Pythagorean identity. The Pythagorean identity says this: sine squared of theta plus cosine squared of theta is equal to 1. So I need to find these things. So cosine squared of theta, oh, there it is, that's y. So I'm going to come down here and say, I did that, that's y. That's equal to 1, and plus, okay, now I need to figure out what is sine squared of theta. Well, I have a sine of theta, so I'm going to somehow convert this into a sine squared of theta. Here we go, zoom in here, work on this problem. I'm going to add 7 to both sides, so this is now x plus 7 is equal to sine of theta. And now I'm just going to square both sides to make this sine squared. So this is going to be squared, and then this side is also going to be squared, and there's my substitution. Sine squared of theta is equal to the quantity of x plus 7 squared. So say over here, x plus 7, that quantity squared. And once you get to this point, you're done. You've solved it. But if you want to simplify it, and I really, really appreciate those of you that do, here's the next step. So I'm gonna box it and then continue on to simplifying this thing. Notice that in the instructions I don't say simplify, so I can't mark off points. If I did say simplify, then you would have to do the following steps. So be warned. I'm just going to let's multiply this out first. So I'm just going to square the first. Let me choose a new color. Square the first. Double the product. 7 times x is 7x. Doubling that is 14x. So 14, that's all 4. 14x, and then squaring the last, plus 49, is being added to my y is equal to 1. And now I'm going to subtract all 3 of these terms one at a time. Well, I'm going to do them all at once now, but think of them as subtracting one at a time. So I'm going to get y on the left-hand side with nothing else on the left-hand side. Everything is moved to the right. I have a negative x squared. I have a negative 14x, and I want to subtract 49 from 1, which is minus 48, or negative 48. And there is the final simplified answer. And so when I saw this yellow, I couldn't tell what was going on. Now that I see what's happening in black, I'm like, oh yeah, it's a parabola, and it's going to be a parabola that's shaped like that, not like that. You can actually tell more what's happening in the simplified version. Our final question. Convert into a parametric equation. This is really easy if you just remember your formula. Here's the formula that you have to have memorized. X is equal to r times cosine of theta, and y is equal to r times sine of theta. Once you have those two, plug them in. Here's your r. Your r is tangent theta plus 5. So I'm going to say x is equal to tangent of theta plus 5. So that quantity, I'll put square brackets. So that is our r. I've written down our r. Now I'm going to write times cosine of theta. Times cosine of theta. Done. Okay, now do it for y. Y is equal to the same thing. Tangent of theta plus 5. Put square brackets around it, or any parentheses, doesn't really matter. And then times sine of theta. Done. Cool. That concludes the pretest 1 for Calculus, or AP Calculus BC.